morning. Is that on? Can you hear that? Yes, excellent. Right, so we've talked about speed. Interestingly enough, this is a wonderful coincidence because Mark Reinhold was talking about speed of delivery. Then we've also been talking about insane velocities at the subatomic level. I will include some physics in this talk, but I'm afraid it's going to be a little bit more fundamental, a bit more Newtonian. And funnily enough, one of the things we were talking about last year, Stefan and I, was, well, let's put it this way. I want to take you back a year to the time that nightmares began. Actually, nightmares began around June, by my reckoning. But the nightmares culminated in an event in the US, which happened to be the first conference day of Devoxx. That came as a bit of a bombshell. We're still waiting for the bombs to actually go off, but that's a matter of time more than anything else. And I talked with Stefan about some talks that I was doing where I was trying to look very much at the connection between developers, what they do, how they do it, and the consequences that they have. So that's kind of what this talk is about. It's a number of different things brought together. But if you were to ask me, what is this talk about? It's about 40, 45 minutes long. That's the best I can do. So move slow and mend things. What do we mean by that? Well, this is clearly in opposition to move fast and break things, which is an old engineering saying popularized very recently by Facebook. And I want to offer a counterpoint here because we have an obsession with just getting things out there. Just a few weeks ago, just in anticipation of this talk, I was talking to a developer. We were kind of looking at something, and he said, I can't get this code working. This is a précis. This is the pre-280 character era, so I have reduced it accordingly. But you can imagine how the real conversation when expanded up to 280. I can't get this code working. Did you check it before integrating it? Yes, checked it in the interpreter. We were messing about with some Python. Did it work there? No. Now, this story is not unique. All around the world of software, there are people going, well, it didn't quite work there, but there's this kind of deep-seated optimism. And to be a developer, you have to have somewhere within you an optimist, because otherwise you wouldn't do it, okay? You may have pushed it down really deeply, but it's still there. There's a deep-seated optimism that, hey, just because it didn't work in the test environment, in the REPL or whatever, you know what? If I just put it in the production system, magic will occur. And it will just, I will cross my fingers and things will collide and it'll all work out. Yeah? And this guy, the funny thing is, this was a recurring story with this guy. It was just like, well, it didn't work there, so I put it over here in the bigger system. It's just like, no, you isolate things. This is the law, the principle of modularity. We make things smaller in order to understand them. It's basic reductionism here. But reductionism is not everything, so I will get to that. So we do have this obsession with speed, and it's not helpful. In fact, the problem actually that we've ended up with is that a lot of the time people reframe. They say, oh no, we're talking about velocity. We even see it in a lot of agile development when people are talking about the progress through a sprint and through their features. They use the term velocity. It really bugs me. It really bugs me. Somewhere in my past, I have a physics degree, and this kind of basic stuff really bugs me. The velocity and speed are not the same. Okay, it turns out that if people did care about their velocity, then that would be a really good thing. Okay, just keeping things flat, we have the idea that velocity has direction. And it turns out that going at high speed in the wrong direction is not helpful. Okay, this is what most projects optimize for. They optimize for speed. They should be focused on velocity. It turns out that if we understood the direction that we were going, we would do better things. Hey, guess what? Our technical debt is rising. Yeah, but we're getting these releases out. Customers are unhappy. We are getting more bugs, or we're getting more code, or we're getting more. We need to focus on all of these things. It's an n-dimensional space that we're actually navigating through. 2 is a very simple number. We can deal with that. But there is this idea that if you are just focused on delivering functionality, you're a crap developer, and your company is going to burn out fairly quickly. Everybody says that speed matters, first to market matters. We know this is a false statement. Anybody here still using Alta Vista? Right, okay. All right, and I want you to think about mobile phones. Again, the operating systems and the phone manufacturers that we're using now. First to market is irrelevant unless you actually care about being there for a while. It's how long are you in the market? Okay, that is what matters. Let your opponents make those mistakes first. Okay, that's what competition is partly about. So if you want to talk about speed, let's talk about speed. What is it? It's displacement with respect to time. Okay, it's kind of a distance. So what is S? Well, let's do this. Let's do this measure. Here's a burn down chart. Here's all the, so S is, I'm going to use a really technical term here, so bear with me. S is short for stuff. Okay, if that's a little too technical, we can replace it with story points or, you know, anything else that takes your fancy. But there is this idea. Here's all the stuff we're going to do, and then we burn down over time. Or I prefer to be a little more constructive. I like the idea of a build-up. I tend to call these build-up charts. Some people call these burn-up charts. I'm speaking as somebody who has a deep interest in space flight and who's also had children who've had fevers. Burning up is a really bad thing. So I prefer build-up. It's constructive, quite literally. If we're going to talk about incremental development, here is incremental. Yeah? After a period of time, you have more stuff than you did before. That is the basis of incremental development. So S is for stuff. Now, the problem here is how do we measure S? This is where our obsessions get a little bit distracted. Okay, so a little bit of dimensional analysis. Time is a time thing. Well, that was easy. Maybe you measure it in days. Maybe you measure it in hours. Maybe you measure it in weeks. Maybe you sit there and, you know, because your development process is so magical and mystical, maybe you measure it in phases of the moon, you know, because that's what you see when you come out at night. Okay, I've just finished the debug session, yeah. Now the question is, what do we measure stuff in terms of? And this is a difficult thing. And unfortunately, although we say measurement's really important, we end up measuring the wrong things. And often people sort of say, well, we're going to burn through stuff. We're going to use proxy measures like story points. Or even if we use real points, we end up with a measure of time. It turns out that in many cases, these measures that people say when they estimate how much effort is this are actually proxy measures of time. This turns out to be a measure of time against time. I wish more people had numerate degrees when they went into project management. This is a measure of utilization. It's not a measure of how fast you're going. It's a measure of utilization, or at best, the quality of your estimation. That's it. You're not actually measuring what people are doing. You're certainly measuring something, and that normally keeps people very happy because there's numbers, and people like numbers. We're not in the petabyte level here, but if people can show numbers with decimal points, that's always impressive. If people say, it's about a week, that doesn't sound impressive. If you say that's going to be, we reckon that's a 43-hour and 22-minute job, it's just like, whoa, that's precision. We really care about accuracy. Precision is irrelevant. Okay, when it comes to building things that we have not yet built before. So how do we deal with the unknown? How do we deal with actually making progress? Okay, it turns out that there's a number of loops that people like. This is John Boyd's OODA loop. John Boyd, US Air Force pilot. He basically this is this kind of orthodoxy of how to teach fighter pilots. What are you going to do? You observe what's happening. You orient yourself. You understand where you're at and where you want to be. Where you're at and where you want to be, that is the basis of the concept of velocity. I am here, I want to be there. This is direction, okay? It's not about the speed aspect, it's about the direction aspect. Then you develop a plan for action, and then in the greatest of Star Trek traditions, you make it so, okay? So the point here is you've got a deliberate approach to this. Instead of running after things, we're going to cycle through things. The idea is that the cycle is a revisiting, and that is a fundamental concept that a linear thinking model does not give us. Now, I'm going to flip this to 180 degrees because that's just fun. Actually, there's a reason I'm doing that. It turns out that people are always pushing these models out, and they're always loopy. Here's another one. It aligns perfectly. The names are different. They've been changed to protect the innocent. PDSA, sometimes PDCA, Plan, Do, Check Act. The Deming-Shewhart cycle. Plan, establish a hypothesis, a goal or what it is that you wish to do. This idea of hypothesis is really interesting. In software development, you are not building what you already know. Okay, we solved that problem a long time ago. Yeah, if you already know how to do it, then it's probably in a library. Okay, if you already know how to do it, it's probably in your IntelliSense. The thing is, you are building something that you haven't built before. Oh, it might be similar to, but it's not identical. The identical problem's been solved. So I've got an idea about how I'm going to do something. I've got an idea about the architecture. I've got an idea about the performance, and I think that this might be the way to do it. I've got an idea about the domain model based on my understanding of the business, and I think this might be the way to do it. I don't yet know, but it's a hypothesis. What do we do with hypotheses? We test them. Okay, so we're going to do something about it. We're going to put that into action. Then we're going to study it. And then we're going to revise. Act here is different from the OODA cycle. And we're going to act. We're going to do something. Now, what's interesting here is this is the foundation of empirical thinking. What you're doing here is you're saying, here's the thing, I've got an idea. Here's a hypothesis. What are we going to do about it? Well, let's just try it. Okay, what are we now going to do? This is the hard bit, by the way. You see there's a line. There's the top half and the bottom half. I often refer to these things as the water line. The water line, if you look at a ship in the water, the bit you can't see is below the water line. An iceberg, it has a water line. There's an awful lot more below it. The problem is that much of our business, much of our day-to-day work is focused on everything that is above the waterline. If somebody says, oh, planning, yeah, I can show you that. I can show you planning in Post-its. I can show you planning in Gantt charts. I've got lots of ways of showing planning. Doing, I've got a whole office full of people doing. Yeah? You can see doingness. You can see doingness in check-ins. You can see doingness in past tests. You can't kind of see doingness in the way that they show in films. My kids were desperately disappointed to discover that software development is not the way it is portrayed in movies. Okay, in movies, you've got some pounding industrial rock, you've got multiple screens, and somebody is just hacking on something. The last minute, the code is projected on their face. That's the reason I do presentations. It's the only way you can get code projected on your face. And it's all very exciting. A room full of successful software developers from the outside, speaking as an observational point of view, is no different to a room full of people looking at pictures of cats on the internet. It is most disappointing. So we have to look around for different ways, different proxies of doing this. So plan and do are highly visible, but study? What does that sound like? What does that look like? We're thinking real hard. And then we're going to think about what we're going to do next. Let's act. It turns out this is the bit that moves you from mere incrementalism and speed obsession to understanding adjustment. So, is this a new idea? It's not a new idea. It's an idea as old as software engineering. Now, software engineering, sometimes people, this is a classic conference, the NATO conference, 1968, Garmisch. And some people say that the conference invented this term. This is not exactly accurate, but there are a couple of things I want to observe here. First of all, just look at the typeface. It's beautiful. It's glorious. This is 1960s. This is Gill Sans, which by an amazing coincidence is the same font that is used for 2001: A Space Odyssey, released the same year. Okay, coincidence? I think not. Okay, mysterious things happen in that film. It's wonderful. Now, the point here is Margaret Hamilton, best known for writing the software for Apollo 11, or being one of the key people there, and basically giving us a concept of what software fault tolerance is about. She coined the term originally. And a lot of people say, oh, well, this set up kind of like things like the waterfall life cycle, and it ingrained this kind of plan-driven thinking rather than plan, do, study, act, plan, do, study, act. We do all our planning in one go, where there's no deliberation. This is not true. Now, I'm not going to say that the 1960s were definitely the epitome of human civilization, although there are days I look at the newspaper and think, yeah, it wasn't so bad. But if we look at various things, this is one from H.A. Kinslow. That's absolutely lovely. The design process is an iterative one. Oh, Boom, 1968. I will tell you one thing which can go wrong with it if you're not in the laboratory. In my terms, design consists of flowchart until, well, obviously there was no other design notation around. But the basic idea of you can replace that with anything you like, but the idea of doodle, draw, think, talk to somebody, whatever it is. But clarify your thinking. Flowchart until you realize, until you think you understand the problem. Write code until you realize that you don't. That is perfect. The rest of this document is so dry, and yet I don't know who this guy was. I've done some Googling about Kinslow. Can't even find a first name, H.A. Kinslow. But some really interesting stuff, but there's some dry humor in there. I love it. Go back and redo the flowchart. Write some more code and iterate to what you feel is the correct solution. We knew the answer in the 1960s. I'm not saying this is perfect, but something happened. I don't know, was it disco? Was it, I don't know, 1970s, yeah? It was flares or disco, one of the two. But, you know, we see within this document there are gems of wisdom. But there is a fundamental thing here. One of my favorite authors, Neil Gaiman, you have to finish things. That's what you learn from. You learn by finishing things. The whole point is to give yourself the opportunity to do something, do it again, learn, move further. Now, what does that mean for software development as a whole? What it means is that there is no concept of design and refactoring. Refactoring is a part of design. There is the bit that you say forward. There is the bit where you say, here is what I think, here is what I'm doing, and here is what I now understand and have learnt, and this is what I change. A full design cycle must include this concept. Otherwise, you build up all kinds of problems, you build up technical debt, and so on. But I'm resting here. We're going to talk about improving the design of existing code. What do we mean by code? Now, for a lot of people, they have a very specific idea of what they mean by code. For a lot of developers, they have a very, you say code, and you know, a programming language or an IDE pops into their mind without them even thinking about it. And when sometimes people, when you ask them about the code assets of their project, they will tell you. But they're normally thinking primarily of like, oh, it's the Java code, it's the Scala code, it's the... And they're thinking of that. No. I'm talking about the tests as well. I'm talking about the scripts, I'm talking about the XML, I'm talking about all of it. It's all code, okay? It all has a formal grammar, it all has a meaning, and without any part of it, something in your system will not run, or there is a piece of knowledge you are missing. So when I say code, I mean it in the broadest comprehensive way possible. But there's another way we can look at it. It's codified knowledge. That is what a code base is. We often have many parallels for thinking about what it is that our code is. But I want you to think about this codified knowledge. It is a basic collective understanding. This is what we currently believe, and this is how we are building it. This is how we've organized it. This is our understanding of the domain. This is our understanding of the technologies, and this is our understanding of how we're going to do this. Now, some of you might be sitting there going like, oh, that's a bit uncomfortable because our system's a mess. What does that say about our knowledge? What it says, there's another way of looking at technical debt, is that unfortunately we have a problem with updating our knowledge. What we find is that when we come to a system, we end up with this is what we thought last week, and what we thought last year, simultaneously with what somebody thought 5 years ago. And all of these are current and present. That is our problem. We would like there to be, this is our current understanding, and have everything be as close to our current understanding as possible, rather than having this kind of like sort of knowledge splurge, okay? You can kind of look at the code, and from a knowledge point of view, you can say, yeah, this is postmodernist, this is pre-Renaissance, you know, it looks like that in some systems. Yeah? So there is that feeling, but codified knowledge, this is a knowledge base. Manage it as a knowledge base. So what does that mean for the very process and practices of software development? If what we're talking about is the gathering of knowledge, and I don't mean just going on kind of new courses and new talks and learning about new APIs, I'm talking about understanding how to work with people, understanding how to work with the domain, learning all of this stuff. It's all knowledge acquisition. That is the primary axis. It's not a production model. Software development is not a production thing. It is a knowledge acquisition thing. The production problem was solved a very, very long time ago. The basis of production is, here is what I want to build, and then it's built. It turns out, and Derek in the previous talk put up Fortran. Fortran is a really important language in history. I wish it would stay there. Okay, I was a Fortran programmer once. If you want to get paid by the keyword, by the line, do Fortran. I recently had to revisit Fortran for a client, and I was astonished at how much code was involved. I mean, earlier Mark mentioned verbosity in Java. It's just like, if you like verbosity, ditch Java immediately. You are in the wrong place, my friends. Yeah, go for Fortran. However, historically very, very important, late 1950s, it gave us a sense of, here is a thing I would like to have built and a way to build it. It's called a compiler. Okay, it's a solved problem. Software development is not a production model. It is a knowledge acquisition process. That is what you do. Now, I would just like to point out that knowledge acquisition is a term that you use to your superiors and when you're trying to make a case for something. So, tell us about your software development process. Well, it's based on a knowledge acquisition model. Sounds impressive. The rest of us just call it learning. Okay, knowledge acquisition's got more syllables, more words, more references to Latin. Learning, nice and simple. So, what does that mean? Well, that means in practice that how do we get knowledge from one place to another? Through communication. And it turns out everything is communication. Face-to-face conversation, the code, those check-in messages, those conversations by the coffee machine, everything. This is all communication. And what we're after is it doesn't matter if one person knows something brilliantly and nobody else does. We need to spread the knowledge around. There is this idea, if you like, that it is not that we lack the knowledge. I think in software development, to be quite frank, based on some of the things I've looked at recently, I think we have solved pretty much all of the problems that software development has ever thought of as a problem. All of the problems that companies are experiencing, or a very large, let me not say all, I have a very precise definition of all, 100%. So let's talk about 95+% of the problems that organizations experience with software and its development are solved problems. The problem is not that we haven't solved them, it's just that we haven't got the knowledge distributed around. It's a little bit like William Gibson's quote, the future is already here, it's just not evenly distributed. We actually know how to do all this stuff, it's just not in everybody's heads at the same time. So we need to get that knowledge around. What does that mean for our view of software architecture and what a code base is? Software architecture is a social negotiation. We tend to think of it as a technical product. And we tend to focus on certain qualities, but actually it's how we talk to each other. What you're doing when you organize a software architecture is arranging who's going to talk to who at what time. What are the things that are going to change? What are the things you don't need to worry about? What are the things you do need to worry about? Which means it's a model of participation. Now that's quite important because software development is one of those things that we definitely know lots of people get involved in. So there is this, for JAX magazine recently I was interviewed, and I made this point, the biggest advantage of autonomously working teams is risk reduction through increased group intelligence. Group intelligence, that's what we're trying to do. I mean, the idea of harnessing up a bunch of developers and sort of attaching them to a machine is very cyberpunk. It's very cool. It's not quite what I'm after, but you are after harnessing team intelligence. But it turns out that just getting a bunch of smart people together is not enough. Okay, there's little correlation between a group's collective intelligence and the IQs of its individual members. Okay, collective intelligence is a slightly slippery phenomenon. It doesn't always work out. Sometimes you end up with groupthink and mass stupidity. Yeah, that may be on your team. In Britain, we have referendums. We've got lots of different ways of demonstrating that. So do not assume you're immune to it. In other words, there's something else here. It's not enough to have individually intelligent people. You need to have a way of coordinating this, a model of participation. How are they getting on with each other? My code is brilliant, but yours sucks does not help because it means overall the code sucks. There's a sharp discontinuity in the code base. And it turns out that the other person may have exactly the same point of view, which doesn't really help. So what we're talking about here is how do we get people working together. This actually comes from a particular piece of research a few years ago. If a group includes more women, its collective intelligence rises. You could be smarter, but I want you to think about this. What we're looking at here is a point that James Surowiecki made in his book, The Wisdom of Crowds. Why the many are smarter than the few? Strictly speaking, what I'm interested in is not why, but when. because he outlines a very specific precondition to an intelligent group, to a smart crowd. The 4 conditions that characterize wise crowds: diversity of opinion. You need to think differently. If you're not thinking differently, then it turns out you're not all thinking. Okay, and the point there is it's okay. We're not talking about toxic individuals. You always get one kind of socially crazy individual that kind of brings down the rest. No, don't recruit them. We're not talking about them. We are talking about the fact that not everybody has to think the same way. They draw. They are not necessarily influenced by other people, and they are able to draw from their own experience and own knowledge. If you recruit people for company fit or people like us, then what you've just done is you've actually killed off some of the greatest inputs to group intelligence. And a lot of these are very standard HR, but also standard ways in which people will run startups. They will look for people like them. And aggregation. It turns out it's no good having all these brilliant ideas. You have to bring it together. The code base is one place you bring it together. The kitchen is another place you bring it together. These are all part of a larger system. So when I use the word system, I use it very differently to the meaning of software system. These are around the software system. The other thing, though, is when we talk about this stuff, when we talk about speed, we're obsessed. We're very simple. We're human. We're very simple. We talk about things like size. It's apparently size matters. We talk about things like scale because it's very impressive from a business point of view. And when we talk about craft, there's this kind of question of like, yeah, these are both watercraft, but it's just like some organizations favor the smaller model. Some say, oh, no, we're doing proper development. And you can sense the proper development or real development comes with its own font and emphasis when they say that. Oh, I see what you're doing. Your recommendations are fine for a little team producing toy FizzBuzz solutions, but we're producing enterprise software. We know this because we've got project managers and we've got enterprise in the title of others. There are, by the way, if you don't use the word enterprise, there are a few others that people like to use. Sometimes projects have the word integration in them. That's always a clear signal. Global is another popular one. There's lots of different indicators. I still prefer enterprise for the Star Trek overtones. But there is this idea that what we do is we get more people and we get more code and we bring it all together and we make it bigger, because this is the basic concept of economics of scale that drove the Industrial Revolution. But it turns out we are doing thought work. We are not doing production work. It turns out that knowledge-based work is not a case of mass parallelism, just launch the cause and see what happens. Software development does not have economies of scale. A friend of mine, Alan Kelly, observed this in Beyond Projects. It has diseconomies of scale. So I wanted to reconstruct an equation, and actually I went a bit further than the equation. I was shown something relatively early in my career. It was a paper, and I'd lost the photocopy, which shows you how old it is. For those of you who are too young to know what it is, photocopying is kind of like a socialized form of scanning. Okay, but I had a photocopy of this paper, and I thought, oh, I'm going to try and reconstruct it, and I discovered I actually went a bit further. So let's just state, it's a simple thought experiment. T is time, T1, completion time for one person. How long is it going to take one person to do all of the software development tasks that we need? Everything that's involved. So I'm not just talking about coding, I'm talking about deployment, I'm talking about the business requirements, I'm talking about the whole thing, all software development related activities. Okay, then we step into modern economics and the Industrial Revolution. We're going to put N people on it, division of labor, okay? 2 people, we're going to go twice as fast. 3 people, go 3 times. Oh, this is fantastic. This is brilliant. Wait a moment there. Can you all do it at the same time? Yeah, it turns out that there's another equation that we may care about, okay? The portion you can do in parallel. Can you do everything at the same time? Now, what happens here? What informs P? What informs P is the architecture, the coding standards, the specialization of roles, the artifacts that are deemed necessary or appropriate for the project. It turns out that we create wait states. Now, you may find it, in many organizations, you don't necessarily find people sitting in wait states looking at pictures of cats on the internet. We use other work to fill up the spaces. Yeah? We organize, we'll always be busy, so, we'll make ourselves busier with that project when we're waiting for that project. The portion in parallel turns out to be absolutely critical. and it reflects the organization around it. In fact, we already know this one. This is called Amdahl's law. We normally apply it to processes rather than people. Okay. However, this is a good opportunity for me to point out this is an idealized model. People are not plug and play, but there's, this is a simplified model. But we go further. What about the fact that people need to communicate with one another and talk to one another? In the worst possible case, you created a work environment and an architecture. You've created a code base and a culture that requires everybody to talk to everybody else at the same time. Okay? That's the worst case scenario. So this is a reflection of your architecture and all of these things. And there is a communication overhead. So this is the worst case scenario. It only gets slightly better, which mitigates that, but there is this idea that you get a little bit of control in that. Now, a lot of people kind of look at that and go, oh, that's really kind of cute. There's lots of parentheses in there. I have no idea. Okay, people love graphs. There you go. Boom. So what do we learn from this? We learn that if you put no developers on a project, you don't get any progress. You also don't get any bugs, so it's not all bad. Okay, it will take infinite time. And as you start adding people, things speed up. But what's really interesting is the form of this curve. The only way you can really change things is by changing the collective knowledge, not the individual knowledge, the collective knowledge, the flow between people, the architecture. There's a few things you can change. You can change the scope as well. The problem is we're very simple. Those all sound a bit subtle. We're very simple. We like the dial called N. We like that dial, and it becomes a self-fulfilling prophecy. Because what you end up with is over here. All the way over here. This is where the consultancies operate. Yes, that'll take 15 graduates to work on your project, and we'll charge you per the person hour. Yeah? It becomes a self-fulfilling prophecy. And then you get organizations say, well, we had a project about the same size 2 years ago, and there were 60 people on that, and that wasn't quite enough, so this time we're going to put 70 people. No, try 30. Try 15, be bold. And this is a point that it turns out that above a certain scale, there is no indication, and we've seen so many different examples in the world of software, there's no indication that functionality correlates with number of people. What number of people correlates with the amount of work, the amount of busyness, and the amount of self-importance. And we end up with some insane examples. One of my favorite ones was this one. Guy took TSA's application. They had a head this way application. Let's see if I got the simulacrum of that here. Yeah, so a head this way, because obviously this is what people need when they enter the US, is you have two security gates there and there, and you have an arrow, and you randomly press it, and it goes left or right, telling you which queue to go in. So that'll really randomize the terrorists. They'll be completely befuddled by this. Whoa, didn't see that one coming. Apparently that cost $50,000 to create and $250,000 to deploy. I want to be the company that was doing that. Okay, it was an iOS application. Somebody created this in 10 minutes in a YouTube video, and you know what? He was using Android, and you know what? He was being fairly relaxed. He was making some mistakes. If he'd really hurried, he could have done it in 5 minutes. So 10 minutes at a slow pace. I decided, you know what, I think I can do better than that. So the thing I just showed you on my phone, I decided, I don't think you even need that. I said, I think you can do this in my least favorite language, JavaScript. Let's just do this. Yeah, we do that. There you go, on load, on click. There we go. It's script. Bit of that. I'm going to be proper. I'm going to put body in. I can't be bothered to put HTML in. But there you go. That's it. That's all you needed. I would like to be, I showed this to my kids. And my teenager just looked at me and said, Dad, why, you could have got paid $50,000 for this? I said, no, son, I'm trying to debunk the industry. I'm trying to get inside there. I'm trying to shake it up, okay? And I said, yeah, whatever, $50,000. And he knows that the pound is in a magnificent slide. It's in a swallow dive to the bottom of all the currencies at the moment. So he's thinking, that's nearly £50,000, So the point here is that typing is not the bottleneck. This is a phrase I came up with about 20 years ago, and Sebastian Hermida a few years ago created this beautiful graphic. Sometimes we approach things as if this is the problem in software development. Maybe it's not production, maybe it's typing speed. Maybe that's what we need. We've solved that. Okay, we'll just give everybody typing lessons, and we'll have the debate about keyboard style and all the rest of it. But this brings us right back to this question. Move fast and break things. Is this a good thing or a bad thing, I was asked? Well, the short answer is it's a thing. It's a context-specific thing. Context matters. When applied within the appropriate context, it can be considered a good thing, an invitation to experiment. I emphasize this idea that experimentation, I think, is fundamental to the nature of software. We are building a thing that is new in some way. It is either new technology, it's a new domain, we've got new people, whatever it is, we are doing something that is novel in some way. Maybe it's mostly novel, 100% of it is, no, nothing's ever 100% new, but maybe it's mostly new and requires an immense amount of research effort. Or maybe it's a variation of something, but the variation means that there are things that we do not know. So this invitation to experiment freely without restraint, to discover new ways of working and thinking. If our job is knowledge acquisition, then thinking is part of that, and maybe we should be open to the idea that you might get a few things wrong, and you want a framework for allowing yourself to get things wrong and not completely screw things up, to break out of an overly comfortable or stuck place. On the other hand, when applied outside the appropriate context, this whole idea of move fast and break things can undermine people in their work. It's quite arrogant, okay? It's quite irresponsible. It means that we start making mistakes because we are being careless, or because we are being careless in the sense of making, not paying attention, but also it means that we don't care in the sense of apathy. So so let's talk about Facebook. We could talk about any social media, but I'm going to talk about Facebook because I had this rather interesting experience where, foolishly, for some reason, I decided I would submit a bug report to Facebook. And I was given the standard reply. I reply, your feedback will be used to improve Facebook. I have not noticed that happening. Thanks for taking the time to take a report. How much time? Look at the timestamp, 31st of December, 1969. That's time travel, kids. That's awesome. That's great, but I don't believe it for a second. Okay? So, I mean, I was alive, but I don't think I was busy submitting or in a position to submit such a report. But that's suspicious. That's kind of like just before the beginning of time. You want to know about the Big Bang? Yeah? So Derek was only dealing with the beginning of time. I'm going back further. There's a progression in these talks, you see. I'm going back to the moment before the beginning. In fact, I reckon it's an off by one error. I reckon it's time t, number of seconds, Unix time, it's gone -1. And it's just taken us back before the 1st of January, 1970. We've got that. So yeah, we've taken a lot of time. In fact, let me take you back 10 years. For those of you who, some of these might bring back fond memories. Okay, this is what the Dutch Rail website used to look like. And yeah, especially the exception. Apparently, it turns out that this was a well-known exception, because I was visiting a friend. I was at a conference in Amsterdam, and my friend was in Duivendrecht, and I thought, I'm going to go and visit him, but let me get an earlier train. There are no earlier trains. There is only java.lang.null pointer exception. Yeah. You can tell how far back this is. I mean, I was using Mozilla, so this is not even Firefox or Chrome. But this is the interesting thing. What we have here is a revelation that tells you a great deal about a system. There's a sort of a question here about what's going on. It's basically, when you drop a system, instead of smashing apples here, I'm going to take some software and I'm going to drop it. And I'm going to see where it breaks. And where it fractures, it shows you the fault lines. It shows you how it was built. It shows you something. At that moment, you lose all encapsulation. If you hadn't already guessed, because of the word servlet, if you hadn't already guessed this was a Java-based application, it's now visible to you. When we say encapsulation, we don't just mean keep stuff private in your classes. We mean just generally. Don't plaster your technology listing all over your URLs. That's, I've got a perfectly encapsulated system, so why can I see .jsp, .rb, .php, whatever in your URL? That's a betrayal of that. And when you get a stack trace, you get this glory, oh, you're using that version of Apache. The point there is there's a failure, and you see inside the system, you see how it was built. So I see it's Java. I also notice other things. Other things like, how did this get through? Surely there's an idea that perhaps you should never, ever let this kind of message get through to a user. Okay, surely there's a big outer try that says, oh, okay, we're going to respond in Dutch or in English, but we're not going to respond in Java. Okay? Surely there's this. And isn't this testable? Can't we test this? And so the other thing is, what kind of culture produced this? What kind of... I sense a group of developers who are under pressure, under speed, which was reinforced a year and a half after this when I visited the Netherlands and at a conference. I used this slide, and somebody came up to me afterwards and said, you know, they still have that. Now, I don't know if this was, at the time, if this was a cherished piece of Dutch culture. You say, oh, no, it defines what it means to be Dutch. You know, this is us. This is how we think, yeah? But to imagine that this bug had been there for a year and a half to the point that random people on the streets knew about it. So I think that team were operating under immense speed. But the quality of the product. Yeah, so anyway, it's got to the point that I collect these things. I collect screenshots, photos of software failure. People now send me this stuff, you know? You can tell the technology, there you go, some PHP. But it's got to the point now that somebody actually coined last year, apparently I'm now a thing, a Kevlin Henny screen it's called. And indeed, this morning on the way in, well done, Paul, wherever you are. So this is fresh. From this morning, on my way to Devoxx, Kevlin Henny at Antwerp Centraal. Brilliant. So apparently I'm now I had a question from a friend recently saying, how does it feel to be identified with software failure? That's a very good question. To the point that there's a conference in Bristol, Agile, where I live, Agile in the City. This was last year. The organizer got me, he said, look, there's a Kevlin Henny screen downstairs. I want to take a picture of you showing the screen, and then I will post it, and then you can retweet it. Brilliant. Anyway, Agile in the City was last week, so we did this. So, you know, this may set up a tradition. Now, the point here is that software failures of any kind can be amusing, and these are often inconvenient and quirky. You're going through a station, and it's an inconvenience. So you're looking at something going like, oh, I was hoping I'd be able to tell what platform I was going to be on, but instead I've got a Windows reboot screen. But sometimes it's more expensive. Sometimes it has greater consequence. This is an artist's impression of the Schiaparelli lander for the ExoMars mission. It was supposed to land on the surface of Mars in October last year. Actually, it did land on the surface of Mars October last year, but as Gizmodo reports, not all was well. Schiaparelli's inertial measurement unit went about its business. For some reason, IMU calculated saturation maximum period persisted for 1 second longer than what would normally be expected at this stage. When the IMU sent this bogus information to the craft's navigation system, it calculated a negative altitude. It's a positive way, it's a very sort of framed way of saying it was underground. So I read the inquiry. You've got to love space flight. Oh, it's an anomaly. An anomaly. You must use this vocabulary next time your system goes down and causes your customers immense distress. We apologize for this anomaly. So I read through it. Because of the error in the estimated attitude that occurred at parachute inflation, GNC software projected the range measurements with an erroneous off-vertical angle and deduced a negative altitude. It turns out that the calculated angle of the craft was over 90 degrees. Now, for those of you who remember your trigonometry from school, if you're taking the cosine of an angle over 90 degrees, then it goes negative, and it turns out that this has some really interesting consequences. It also turns out there was no check for this impossible situation, because that could never, ever happen. And so what happens? Well, this thing now thinks it's on the ground. So what it does is it says, hey, guess what? We need to go into landing mode. So it ditches the back shell, it ditches the parachute, it does all of this, puts out the landers. Oh, brilliant, absolutely. Only one problem, you're 3,700 meters above the ground. Now, it turns out that although Martian gravity is only about 2/5 of Earth's, anything more than 0 is significant. And so indeed, Schiaparelli did land, and they've seen the crater from orbit. But what we're looking at here, it's a really interesting point here. Simple testing can prevent most critical failures. This is this wonderful paper that looks at a number of production systems. And one of the most interesting ones, almost all catastrophic failures are the result of incorrect handling of non-fatal errors explicitly signaled in the software. And it turns out that we can recreate about 3/4 of these if we try. It turns out that there is a really interesting point here. Now, when people look at, when they think about software failure, when they think about testing, they are looking very much at a narrow view of what's involved. They are thinking of the technical stack. They're thinking, oh, testing will slow things down. But I want to present to you the idea that actually testing is a much, much bigger thing. There is this idea that, yes, testing does slow you down at one level, but it allows you to avoid certain surprises. This idea of thinking of the technical stack beyond a system gives us this idea. It's a wonderful book, Christmas is Coming. Always design a thing by considering it in its next larger context. When people focus on algorithms, when they focus on the basics of their code, they focus on simple correctness ideas. And they don't focus on interesting consequences. So to go back a year, we have this interesting one. I'm not just blaming Facebook here, it's just that they have a readily identifiable brand. It's true of many things. Facebook is now in the awkward position of having to explain why they think they drive purchase decisions, but not voting decisions. Their systems are optimized for giving us more of what we think we want. They are organized to influence. And how much do they influence us? Some of you may or may not be aware of this experiment that Facebook ran a couple of years ago. We show via a massive experiment on Facebook that emotional states can be transferred via emotional contagion, leading people to experience the same emotions without their awareness. That N equals nearly 700,000 is a reference to the number of participants who did not know that they were volunteering for this. And this is quite important because Facebook actually changed its terms and conditions about a month after this to kind of retrofit it. It turns out that you can make people happier or sadder at this mass influence level by adjusting the content of their feed. And the point is that feed was optimized for one particular reason, and it does it very well. But now what we're doing is we're seeing this stuff, and a lot of people go, oh, this is terrible, this is terrible, this is just like A/B testing. You see, A/B testing is based for a commercial product. There's the idea of, well, yes, if we use this approach, it empties people's bank accounts to buy our products faster. Now, is that more or less moral? I'm not going to answer that question. I just want to offer you the sense that when we come to test and frame and specify and think about our systems, there is a continuum somewhere between innocent A/B testing, what is the better website, and extreme emotional contagion with major side effects. And if we're running around at speed, we're going to miss stuff. So what I like to do is just end with this idea that, yeah, move fast and break things makes sense. But we need to understand the context in which it makes sense. Software is by its nature an experimental activity. It's also utilitarian and commercial activity, and we need to understand where those boundaries lie. And we need to understand that some of the time we need to kind of pause. We need to slow down. You get faster sometimes by pausing. Okay, in other words, don't spend more time doing the wrong thing with greater energy. That may look more visible, but it's a case like, hang on, what would be the better option here? What mistakes have we made that I can now fix? And ultimately, it comes down to learning. Thank you very much.